I'm Clint Finley. I'm here at the Contact Summit with Paul Hartzog of the Future Forward Institute. He's here demoing something new he's built called Flows. Paul, could you talk a little bit about Flows?
Yeah, absolutely. I mean, it's great to come to a place like this and talk to interesting people and find new ideas. There's a lot of people here with great ideas. Flows is an idea that evolved over my realization that things online were not interoperable. And I find that to be a huge problem because we can't discover new things and interact with them. And without that, we're not going to get the kind of rapid innovation that we need online. And so what has happened in the history of the internet is we've sort of converged on a lot of conventions. You know, we use HTTP as a protocol, we use certain kinds of data transmission formats, XML and JSON and whatnot. And even down to the hardware layer, we're stuck with things like TCP, IP. And I've been at the University of Michigan studying complex systems, and one of the things that we learn about is that when you have more diversity and rapid innovation, you're going to get more interesting combinations of things, and your system as a whole is going to be more robust, it's going to evolve faster, it's going to be more stable. And on the whole, it's just a better way of organizing things. It's the reason ecologies are organized that way. It's the reason that biological organisms have the structure that they do. And social structures have the same kinds of dynamics. And so I started thinking, well, what if there was a way to make everything that goes online, whether it's on the web or the internet, or whether it's part of your car or part of a building or a device that you have in your hand, intelligent in such a way that you could ask it, what are you and how do I talk to you? Right? So that right now, if you want to request a web page, you have to already know that you're communicating on HTTP, and you have to already know that you're requesting an HTML document, so that when you get the response back, you know what to do with it. And what that does is that means that the intelligence is on the side of the person making the request. Well, the reason the internet evolved the way that it did is because the intelligence was pushed down to the endpoints. The old AT&T phone networks, all intelligence was centralized in the main infrastructure building and all that. And what made the internet grow so amazingly was that the intelligence was pushed into the endpoints. So I started thinking, well, what if you made intelligent objects? So now the flow system basically has a dumb request order that's capable of asking first. It's a principle I call ask first. And you ask any object, what are you, how do I talk to you? And the object says back, well, I accept certain kinds of requests, and I will give you certain kinds of responses. And there could be all kinds of metadata in addition to that, but we need at least that in order to know how to talk. And so there's the basic example is if you imagine two people, and one speaks English and one speaks French, and they want to have a conversation, there have to be two kinds of communications. The first communication is a how do we communicate, right? And maybe they'll settle on the French language, or maybe they'll settle on the English language, or maybe they'll settle on sign language. But without that initial investigation and discovery, you can't move to the important phase, which is actually communicating and getting things done. So let's say you have some computer object that adds two numbers together. This could be a web page, or it could be a functional object in some piece of distributed code. Well, the first thing you'd say is, who are you and how do I talk to you? And it would say, well, I'm an adder. I add two numbers together. And the second thing you would say to it is, oh, well, here's two numbers. What's the sum?
So it sounds like what you're describing is a way that you can discover a website's API or an application's API. How is this different from some of the existing API technologies that are out there, like RESTful APIs?
Yeah, well, actually, the tests I've been doing have been using RESTful APIs because it's easy to do. It's easy for me to run my tests. But the really intelligent thing is you can take a robot, which, for example, can detect heat or blinking light, or it can tell whether the floor is level or tilted. And those are other ways of sensing the environment. So the theoretical limits of asking first extends far beyond computational objects. They don't have to be protocols that are online. You could basically have an object like a robot that you could put into a space, and the first thing it would do is query the environment to see what objects are in that environment, what kinds of ways that it can communicate with that environment, and then it's ready to go. Right now, we have to pre-program all of it, right? So the problem with current API programming is it's build your functionality first and your API second. And so the API documentation lives over here, and all the functional code lives over here. Right? What I realized was that you can take the little bits of API and embed them directly in the objects themselves as a kind of structural metadata. And what that would mean is that you can query any object. And essentially, you're asking it for its personal API. You're saying, how do I interact with it, right? And what that does is it means that everybody who wants to develop code doesn't have to get together and agree ahead of time how we're going to make things interoperable. And this is a really, really crucial point. It means that anybody can go develop anything, and as long as their objects are queryable, as long as they've committed to that idea of queryable objects in an ask first principle, they can put those objects onto a worldwide internet very easily, and other people can come along and write tools. Sorry. They can write tools that will interact with them. And so what that does is it means we're going to get rapid innovation because we don't have to agree on everything up front. We don't have to have lots of conferences and lots of protocols and procedures and rules. And the other thing that happens in that kind of ecology is that it means that, let's say that you have an object, but it doesn't give me what I want. Well, a third person can come write essentially a proxy object that will take what you do give, refactor it into something else, some other kind of response type or delivery, and I can query that object instead. So because we can continually write intermediaries, they function as translators. We can translate from anything to anything, and we never have to stall rapid innovation by having lots of agreement and consensus up front.
So you kind of route around the need to standardize on a data format that,
Yes.
that the machines respond
And it doesn't mean that the ecology won't have certain standards. What it does mean is that those standards will be emergent. We'll see them evolve as certain kinds of usages increase, just the same way we saw a lot of people start to use JSON, even though XML was a perfectly viable alternative in many cases. That kind of emergent standard, where we think of it as standards, some are more in use than others, that's the kind of healthy, robust development ecology that we need to have in order to build the kind of emergent shared infrastructure that a lot of us want to see.
Actually, one thing that just popped into my head is this actually kind of sounds like, in the old command line days when you got a new application, one of the first things you might do is just type help, and it would just give you a list of commands that you can enter.
Absolutely. Now, way back in the old Unix days, you get on the command line and let's say you type a command and you do it wrong. Well, the command would immediately come back and give you a human-readable help page. If you wanted that help page anyway, you could type man, M-A-N for manual, and the name of the command that you wanted help on, and you'd get that same help page. But the point was that information, that metadata about how to use that tool was already there, already accessible, and for some bizarre reason, I really don't know why, it just probably slipped by people, that idea, such a profound idea, never made it to the web. Now we're seeing things like RDF triples and the development of APIs, but all of those things are very, very recent, whereas they probably should have been embedded into the core infrastructure of connecting objects in the first place, way back when the internet first came about. That's my opinion.
So how can people get involved and find out more?
Well, obviously, Google, Paul B. Hartzog, Flows. We have a website at the Future Forward Institute for Flows. You can contact us, Twitter, Paul B. Hartzog on Twitter. Obviously, we have email addresses at the Future Forward Institute. So I'm sort of ubiquitous online. I'm sure that you can find me by many ways.
Well, thanks a lot for your time, Paul.
Thank you so much.